composite functions. That's basically when we combine two functions together. So if I start with these values for x, 1, 2, 3, 4, 5, I can plug it into this function, 2x plus 1, and then 1 goes to 3, 2 goes to 5, 3 goes to 7, 4 goes to 9, 5 goes to 11. But if I now get that output and input it into another function, so x has gone to 2x plus 1 at this stage. Those answers I'm going to put into 3x squared. So now the 3 goes to 27, 5 goes to 75, 7 goes to 147, 9 goes to 243, 11 goes to 363. The same thing could have been achieved by just subbing x straight into 12x squared plus 12x plus 3. It's the composite of those two functions. If I sub function x into g of x, then I would get 12x squared plus 12x plus 3. If I was to do it the other way around, if I was to substitute g of x into function x, you're not necessarily and probably not likely to get the same answer. It'll come up with a different function. So for this one, had I substituted g of x into function x, I would have ended up with 6x squared plus 1. So how do we work out the domain and range of these composite functions? So for x to be in the domain of the composite, there's now two things we have to think of. It's got to be in the domain of the function that we're substituting in. If I can't put it into g of x, then I can't get an answer to go and put into function x. So it has to be in the domain of g of x. But what it also now means is the output, so g of x, has to be in the domain of function x. So we need to look at the range of g of x to see whether all of those are possible to put into the function itself. And then for range, so a value is in the range of the composite only if the x value that produces it is in the domain of that composite. Let's look at an example. My function x is going to be 2x on 4 minus x. My g of x is going to be 1 on x squared. We want to find the domain and range of the composite function when I substitute g of x into function x. First condition was x must be in the domain of g of x. So let's have a look at g of x. G of x is 1 on x squared. I know the domain of that is all reals except for x equals 0. X can't equal 0 on that one. And I might as well work out the range while I'm at it. The range for that one, well, it's always going to be positive. It's always going to be greater than 0. Now what we're substituting into the domain of that function would be all real x except for 4. And the output of that, I'd get all real values except for negative 2. So we said x must be in the domain of g of x. So the first thing I know is x can't equal 0 because that was the exclusion for the domain of g of x. But we then said g of x must be in the domain of function x. So the output has to be. Now, we said, let's go back to it. So in the domain of function x, I could get every number except 4. Therefore, g of x can't equal 4 because g of x is the output. That's what I'm substituting in. It's not allowed to be 4. Therefore, 1 on x squared can't be 4. So x can't be plus or minus a half for this composite function. There's my domain for the composite. I've got all real x, but I've now got 3 points of exclusion. 0, plus or minus a half as well. Now to work out the range. You might find it easier to actually work out what the composite function is. So for this one, the composite function is 2 on 4x squared minus 1. That also then highlights the other exclusion in the domain over here, that x can't equal plus or minus a half. So you might find that an easier way of working out the second point of exclusion, actually work out the composite function. But when I look at that composite function, the range of it is that it's less than negative 2, but also greater than 0 as well. But remember, I'm not allowed to substitute 0 into this function because that's an exclusion in the domain. And when I substitute 0 in, I actually get the value of negative 2. So now I have to just update my range of the composite to take out that other point of exclusion. The range becomes less than negative 2 and greater than 0. Let's flip it the other way around. G of function x. X must be in the domain, so this time x can't equal 4 is our point of exclusion. But now, let's work out the other one. We're saying function x can't equal 0. because we're not allowed to put that in. So 2x on 4 minus x can't equal 0. I get my 2 points of exclusion. But again, you might find it easier to work out the actual composite function first. There it is, highlighting again that, hey, x can't equal 0. Now the range of that particular one would just be the composite functions greater than or equal to 0. But we said x can't equal 4. Therefore, that function can never equal 0. So let's update our range and we have our answer. So possibly the better way, or easier way, what's a better word? Better? Easier? Work out the composite function, and that brings out that second point of exclusion very quickly for the domain. Now, if the domain is actually empty, so there's no value, I mean, it's a weird function, but it's possible that there are no values in our composite function, or any function for that matter, then that function is what we call the empty function. The empty function. 4e we'll have a look at.